Hello student, the question says a wire of cross-sectional area A, modulus of elasticity 2 into 10 power 11 Newton per meter square and length 2 meter is stretched between two vertical rigid support. When a mass of 2 kg is suspended at the middle, it sags lower from its original position, making an angle theta equals to 1 by 100 radian on the points of the support. The value of A is. We can clearly see the angle theta is very small and even x is given lesser than L. Now let us draw free body diagram for this 2 kg mass. Like let us draw free body diagram at this location. If I draw free body diagram at this location, so we have a force mg in this way. Because this is a rope, we get tension T in this direction, and this is one more rope, and we will get tension T in this direction. So we have tension T and T, and this angle is given theta. If this angle is theta, we can write this angle also as theta. If this is theta, this angle also would become theta. So based on that logic, let us resolve this T into two components. If I resolve this T into two components, in this direction I will get T sine theta. In this direction I will get T cos theta. In the same way, if I resolve this T into components, I will get T cos theta. And in this direction, I will get T sine theta. Now, finally, the T cos theta on the left side would balance the T cos theta on the right side. And this 2T sine theta will balance this mg. So we can finally say 2T sine theta equals to mg. We can write here theta is very small because it is given 1 by 100 radian. Since theta is very small, we can write this as 2T theta equals to mg. From this, we will get the value of tension as mg by 2 theta. So this is one expression that we are going to use in solving the problem. And the next one is that we have to find how much our rope actually elongated. So to do that, we can take a triangle that is present here based on x and L. So this is L and this is my x part and this is the new length. So this is x and this is L, and let me call this theta. So let us assume this is the new length. Okay, let me call this L1 and let us call it as new length. So the new length would be equal to simply root of x square plus L square. Suppose if I get L outside from this, so L if I get outside, so I'll get root of x square by L square plus 1. So we get, if I bring L outside, we'll get root of x square plus L square plus 1. We know in binomial expression, we can write this as L into 1 plus x square by L square whole power 1 by 2. So in binomial expression, if 1 plus x whole power n is equals to 1 plus nx, if x is lesser than 1. So using the same logic, I can write this as L into 1 plus 1 by 2 x square by L square. So finally, the new length on solving, we will get L plus, I open this brackets, x square by 2L. So this is one thing we got. So L new is L plus x square by L. Then what is the elongation? So this rope, whatever rope that we are seeing here, this is under tension. Because of this, it elongated. So elongation is simply L new minus the original length of the rope was L. Before putting this mass, the original length of the rope was L. So L new minus L, if I do it, we'll get it as x square by 2L. So the elongation in this rope is x square by 2L. So we got elongation in the rope. And let us identify what's the relation between x, L and theta. From this very figure, we can write, so I'll take it to the next page. We can write tan theta is equals to x by L. So we can write x equals to L theta since theta is very small. And we also got from the previous expression, elongation is equals to x square by 2L. So in place of x, if I write it, I'll get L square theta square divided by 2L. So the elongation value is L theta square by 2. So this is the value of elongation. Now, why do we need all this information? Because he is asking us to find the area of cross section of this. To find the area of cross section, we will use the concept of Young's modulus. We know force is equals to elastic constant into elongation. Like it is similar to F equal to kx in a spring. This is similar to F equal to kx in a spring. Or you can use Young's modulus is equals to stress divided by strain. I personally like to understand things in this way rather than in this model where elastic constant is equals to YA by L into E. The same thing, if you rearrange the terms, we will get FL by A into delta L is nothing but elongation. We need A. So based on this, we will get A equals to either you rearrange the terms or rearrange the terms, you will get the values FL by A into Y. Sorry, FL by E into Y. Now let us substitute everything that we know. We got force equals to mg by 2 theta. So we got this as mg by 2 theta. Length is L divided by elongation. We got L theta square by 2. And finally, we got 1 by y. So the area of cross section is simply mg. L we can cancel, 2 we can cancel, mg by y theta cube. So we ended up with this expression A equals to mg by y theta cube. Let us substitute everything and find the value of the area of cross section. So we got A equals to mg by y theta cube. So m value given in the question as 2 kg, g value is 10, Young's modulus is given as 2 into 10 power 11, and theta is given as 10 power minus 2 radians. Theta is given as 1 by 100 radian. So we can write it as 10 power minus 2 radian. So 10 power minus 2 whole cube would be 10 power minus 6. And the answer, if you look at the question, the answer is given in terms of n into 10 power minus 4. We have to find the value of n. So the answer is given as n into 10 power minus 4 equals to 2 into 10 divided by 2 into 10 power, I think it is 5. So we'll get n equals to 2 into 10 power 10 into 10 power 4 by 2 into 10 power 5, which is nothing but 1. So implies the value that we are looking for, it is n equals to 1. Again, I will repeat, the key points in solving the problem is what will be the elongation. It is better, even before solving this problem, if you directly know if something sags by theta, what will be the new length? The new length would be, the elongation would be x square by 12. If you know this expression beforehand, it will save a lot of time while solving the problem. But anyway, these are the step-by-step methods to solve the problem. But if a student is solving it, he will not draw these free body diagrams. In his head only, he would be directly doing 2t sine theta, 2t sine theta. Quickly, we'll rearrange the terms and we get the value as t theta, t into 2 theta, and we get this expression directly. And after this, we will not solve it in this much detailed way. We have to come to the conclusions as quickly as possible. Hope you understood how I have solved. Thank you.